All right, class is number 44. Right now we have 6 unknowns and 2 equations. If we can get rid of a few of these variables, then we can solve this. When you have 2 equations, you need to get it down to 2 unknowns. So we're going to have to start eliminating some of these variables so we can solve it. All right, while reading through the problem, I know that T1 is going to be flying for 2 hours. T2 is going to be flying for a half hour less than that. So 1.5. R1, we don't know what R1 is. Okay? So R1 is just going to equal R1, but R2 is going to be 80 plus R1. The distances, again, we don't know the exact distance of each plane, but we know that if we add them together, we get a total of 3,200. Okay, so here's a little trick you can use. You can say D1 is just going to equal D1, but then D2, we can solve this equation for D2, and it'd be 3,200 minus D1. Okay, so now we've eliminated R2, and we've eliminated D2, we've eliminated T2, and we've eliminated T1. I'll show you how. Because if I start substituting in, we don't know D1, so let's just leave it as D1. We don't know R1, but we know T1 is 2. We know D2 is going to be 3,200 minus D1. And R2 is 80 plus R1. And T2 is 1.5. So now I have 2 unknowns and 2 equations. I can use elimination or substitution to solve this. I see substitution real easy for this problem right now. I'm going to take this and put it in for D1. So 3,200 minus 2 times R1 equals 120 plus 1.5. Should have used a different color, just so it just sticks out here. Equals, so what I'm doing is rainbowing. So 1.5 times 80 is 120. 1.5 times R1. There we go. Now combine like terms. So I'm going to subtract 120 from both sides. I get 80. Add 2R1. I get 3.5 R1. Divide both sides by 3.5. $30.80 divided by 3.5 is 880. So R1 equals 880. R2 is R1 plus 80. So R2 is going to be 960. And these are both kilometers per hour.